Alright, hello Algebra 1. So we're just going to be doing some notes today, and then you'll have some time to work on your homework, and that's going to be it. So we're going to start off by kind of figuring out a little bit of pattern, because we will need this when we do the actual graphs of exponential functions. So first three problems here. We need to state the initial value of each equation and then find the y-intercept, because that's going to help us graph it later on. So for question number 1, we have y equals 4 times 2 to the x. Okay, so the initial value, remember, is just the number out in front. Okay, that's what initial means, is the first thing. So a is 4. And since a is 4, that tells us exactly what our y-intercept is. It is 0, 4. That relationship is always going to be there. Alright, so if we were to sketch a little graph here, we would pass up here at 0, 4. Alright, now also we could look at the 2, and we know it's supposed to be exponential growth, so it's going to be going this direction and getting bigger and bigger. So just a quick sketch to kind of get that in our brain. Alright, so looking down here at question number 2, our initial value, the number that is in front, is 11. So that means our y-intercept is 0, 11. And again, if we were going to sketch a graph, this is a bit more outrageous, because 11 for our graphs, the ones that we normally do, would be way off the graph, okay? But we're up here at 0, 11, and then it is a 4, which is bigger than 1, so again, it's going to be growth. So it's really going to be increasing there. Okay, going down this direction towards our asymptote in this direction. So just quick sketches, okay, to kind of get an idea of what's happening. And for the last question here, question number 3, we have y equals -6 times 7 to the x power. So our a value, our initial value, is -6. All that means is our y-intercept is 0, -6. Sketching a little graph, that just means we are down here. Okay, 0, -6. That's where we're crossing the y-axis, and actually we are multiplying that distance times 7. So as we go to the right, that distance is going to get larger and larger and larger. This is actually exponential growth, because that is bigger than 1. It's just growth in the negative direction. So a little tricky, but that's all we have to do for the first couple of problems. We're going to use this idea when we go ahead and graph these exponential functions. Now, as we're going through the notes, if you guys need to pause, okay, so you can write things down, I'm more than happy for you guys to do that. Now, yesterday we were filling out a big XY table. Today we're going to be using some shortcuts in order to graph these exponential functions. Okay, so it just takes 2 steps. Step number 1 is to take the initial value from the equation and plot this as our y-intercept. So let's go ahead and write that out. Take the initial value from the equation and plot this as our y-intercept. Okay. And if you can't read my handwriting, go ahead and pause it. You can kind of decipher it from here. But that's our first step. But that's exactly what we did in the first 3 problems. Step number 2 is to multiply by the growth or decay factor, that number in parentheses, as you move to the right. Okay? So that's step number 2. Multiply by the growth or decay factor And again, that's the number in parentheses as you move to the right. Now, if we needed to go to the left, okay, going the opposite way, you would do the opposite pattern. Okay, so I'll just make a little note here. Do the opposite pattern. As you move to the left. Okay, so these are the two steps that we're going to use to quickly and easily graph exponential functions. Let's move on to question number 4 then. Okay, for question number 4, we need to graph each exponential function without creating an x and y table. Now, if you still need to, I'm not opposed to that. It just takes a little bit longer. There's a little bit more work involved with that. But to do it with the shortcuts, the two steps that we just listed, we need to look at the initial value. So that's the very first number in our equation, which is a. A is -4. Since a is -4, that just means that we cross at 0, -4. After we do that, we can go ahead and plot that. So 0, -4, that is over 0, and then down 1, 2, 3, 4. So we have a point right here. Pretty easy. After we do that, the next thing we need to look at is that number in parentheses right up here. So 2, that's our b value. Since 2 is bigger than 1, that just means that we have exponential growth. Alright, and just as a typo, so you can just scribble that out. I don't know, Microsoft Word must have bumped it over. So we have exponential growth because b is 2, which is bigger than 1. So that's the pattern that we're going to do. Okay, let me circle this. This is our pattern. So we need to take -4 and we multiply it by 2. Well, -4 times 2 gets us -8. So as we move to the right, that is where we put our next dot. Now if we were to move to the right again, -8 times 2 would get us -16. That won't even fit on our graph. So we're kind of out of space at this point. So what we need to do is we need to go to the left. So from -8 to -4, we divided by 2. From -4, we divide by 2 to get -2. So we're doing the opposite pattern as we're moving to the left. We take -2 and we divide by 2 and we get -1. So we're just kind of chopping that number right in half. -1, if we chop it in half, or if we divide by 2, we get 0.5 or 1/2, -1/2. We can chop that in half and get 0.25 or -1/4. If we chop that in half, we get -1/8, and we just keep getting closer and closer and closer to that asymptote, which is right here. Okay, so then we go ahead, we draw in our exponential. Oops, kind of missed my big dot here. So let's go ahead and draw in our asymptote. I'll do it in red. So it's right on top of the x-axis. And we just get closer and closer to it as we go on. Alright, so our domain, the pattern that we've kind of seen, we are going left forever and we are going to the right forever, so we are using all x values. I hope that you're kind of sensing a pattern here, and on the questions on the quiz and the test, you can get some free points because it's always going to be that answer. We're always going to use all x values because you can put anything you want in up there for that exponent of x. Our range is y values, since domain is x, range is y, and we used only the y values down here. Okay, we didn't use any up here. There's nothing up here, no graph, nothing. So how we say that is our y values are small. They are smaller than that asymptote, so they are less than 0. Okay, since that asymptote is located at 0. So the equation for the asymptote, because we haven't learned how to move it around, is y equals 0. Alright, so no table of values, nothing. All we had to do was kind of look at our equation, graph our initial value, follow our pattern, and we got it from that. Let's go ahead and try the next problem. Y equals 2, and then times 1/2 to the x power. So our initial value here is 2. All that says is we cross through 0, 2, so let's go ahead and put that point on here. So over 0, up 2, there's my dot. Now we look at our b, the second number, the number in parentheses, the base, and that is 1/2. Since it's a small number, less than 1, this is exponential decay. Alright, sorry about that, that's my hard drive working overtime. So exponential decay. Now what we're going to do is we're going to follow this pattern. Okay, so we're going to multiply everything by 1/2. So if we take 2 and multiply it by 1/2, we get 1. Okay, we're just chopping it right in half. 2 chopped in half is 1. 1 chopped in half is 1/2. Okay, right there. 1/2 chopped in half is 1/4, or 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8, and so on and so forth. A 16th, a 32nd, a 64th, a 128th. Okay, so it's just getting smaller and smaller and smaller. We will never be in the negatives though. Very important. Now if we wanted to go the opposite direction, 1/2 is doubled to get to 1. 1 is doubled to get to 2. 2 is doubled to get to 4. So that's how we get to the numbers on the left. 4 is doubled and we get to 8. So we can go ahead and draw our line through all these points. Let's go ahead and draw in that asymptote that lets me know, hey, we're not crossing this invisible fence. Okay, we're just getting kind of close to it as we go further and further out. So our domain, again, x values, we are using all of them, all x values, because we never stop going left and we never stop going right. For our range, our y values, we didn't use y values down here. We only used y values up here to graph things, so we say y is bigger than 0, because at y equals 0, that's our asymptote, that's that red dashed line. Okay, so hopefully you guys are starting to get the hang of this. If you need to pause it to be able to write some of this down, please feel free. To keep the video short though, I'm going to keep moving on. For 6, 7, and 8, what we're going to do is we're going to look at the graph and we're going to see, what's the equation? So this is going backwards. Normally we write the equation, we write the graph. We're going from the graph to write the equation. Also an important skill. So to do this, we first look at our y-intercept. Okay, so our y-intercept is right here, down 2. So that means that's our initial value at -2. Okay, because we were down to right here, right there, so -2. Now, what that says is we have 0, -2 as our y-intercept, and we can start writing our equation. Okay, so remember, our equation should start with y equals, and we can just go ahead and put that initial number, that initial value of -2 in here. What we don't know is the number in parentheses. That's what we have to figure out next. That is our growth or decay factor. So what we do is we look and see what did we do to get to the next dot. So we had -2, then we were at -4. What did I have to do? Okay, I timesed by 2 to get there. -2 times 2 is -4. So that means my b is going to be 2. That's the pattern that I'm doing. If I take -4 and I multiply it by 2, I should get the next dot. -4 times 2 is -8. And there I land. So that's a quick, easy way to see if you guessed the right number, if you're seeing the right number. It is exponential growth. Okay, it's just growth in the negative direction. And we can go ahead and fill in our base, our b. And don't ever, ever, ever forget, we need a little x up in the exponent spot. So that's how we do these types of questions. Start with your y-intercept, which would be your initial value. Figure out the pattern to get to the next dots. For number 7, we're just going to do the same thing. So I'm looking here, we cross at 0, -4. So that just means my initial value is -4. So when we're writing our equation, we start with y equals, we put -4 in front. And now all we have to do is figure out, hey, what number is in parentheses here? How do we get to the dot over to the right? So we're at -4, now we're at -2 right here. So how do we get from there to there? Well, all you have to do is take -4 and you divide it by 2. If we take -2 and we divide it by 2, we get to the next dot right there. If we take that dot, divide it in half, we get to the next one. So we have this repeated pattern of dividing in half, which simply is multiplying by 1 over 2 or 0.5 or anything like that. That's the b value that goes in here. And since it is a small number, it is exponential decay. We are getting smaller and smaller and smaller and smaller as we're going to the right. Okay? That distance is getting smaller and smaller. Exponential decay, we have negative 4 times 1/2 to the x power. Can't forget that x up there. And that's it. That's all you got to do. So let's try the last one here. It's going pretty quick. Alright, let's find our initial value. So it looks like we are crossing somewhere between 0 and 1. Now I'm not sure exactly where this is. This might be a half, this might be a quarter. I don't know. So maybe let's see if we can find some other points that will make us feel a little bit better about what this y-intercept is right there. I know we have 1, 1. That's right here. Okay. What do we do maybe to get to this point? 2, 3. Well, we took this distance 1, and to get to 3 right here, we multiplied by 3. Okay, so let's see if that works for the next one. So we're standing on 3. We need to get to this point. This point is 9. So we were at 3. How do we get to 9? We multiply by 3. So we went from 1 to 3 to 9. That's the pattern that's happening. We're multiplying by 3 as we're going to the right. So we're not starting with our initial value. For this one, we're starting with our growth or decay factor, our pattern. So our pattern is multiplying by 3. And the reason that I'm doing that, again, is because I don't know what this point is. But I can use my pattern now to figure out where this y-intercept is, right there. Since it is 3, that means it is growth. Okay, and obviously that's what's happening as we're going to the right. It's growing, getting bigger. So all I have to do is I take 9 divided by 3 gets me 3. From here to here. 3 divided by 3 gets me 1. From there to there. So to figure out this y-intercept right here, I take 1 and I divide by 3. 1 divided by 3 is simply 1/3. So that's where that dot is crossing, okay? It was kind of hard to tell. We didn't know if it was 1/2, 1/4, but it is 1/3 right there. So that is my initial value, 1/3. 1/3. So that's my y-intercept as well, 0, 1/3. So now, since we have the a and we have the b, we can go ahead and write the equation. Y equals our initial value, 1/3, and then our growth or decay factor, in this case it's growth, 3, all raised to the x power. That is our equation. And if we were to try to find the next dot, this would be 1/3 divided by 3, which is 1/9. Okay, so you're kind of seeing that pattern. Very good. Alright, so I suspect once you get all these notes, you'll be like, yeah, what do we do? Okay, Mr. Williams is going to give you guys time to work on your homework, okay, and I expect you guys to actually be working on it, try to get it finished up and turned in since this video is not very long. You can go ahead and put it in your folders. Once you get done, there's kind of a cool thing you can do with exponentials and a piece of paper, okay? So let me kind of draw it out for you real quick. If you take your piece of paper, okay, so let me draw it. You have your piece of regular white paper. You can go ahead and you can see this kind of exponential pattern by cutting it right in half. Okay, so we're dividing it in 2. So then you're going to take your half sheet right here, because usually you'll cut it or you can tear it, whatever you want. And you can cut that in half. So I'm just going to keep cutting it in half. Okay, so that went to here. We're going to take this one, we're going to cut it in half, and what we are doing is we are creating an exponential pattern. So these slips of paper are going to keep getting smaller and smaller and smaller. So if you wanted, okay, see how many times you can do this. You can basically do it forever. Will you ever run out of paper? Okay, will you ever work yourself down to something that you can't cut anymore? All right. You can kind of see we're getting smaller and smaller as we're going that direction. That would be a pattern for exponential growth. Another thing that you could do if you're bored and sitting in math class and you're like, man, Mr. Johnson, just shut up, is you can go ahead and draw a square. And with your square, you can divide it into fourths. So just divide it in half again. Now, we've divided it into 4 pieces. Let's pick one of them. So I'll just pick this one right down here. And we are going to divide that into 4 pieces. So all I do is I split it like this, split it like this, and now I have 4 little pieces down here. Okay, and I can keep on doing that. So maybe let's split this one into 4 pieces. And they keep getting smaller and smaller and smaller and smaller. See how far down you can go. This is called an exponential decay. So each box is getting smaller and smaller and smaller and smaller all the way down to infinity. Okay? If you wanted to look up some cool stuff about this, you could go ahead and look up videos about Vi Hart. She is a mathematician that does doodles and things like that, and I'm sure if you looked up Vi Hart with the word exponential, you would find some cool movies. I think she does some about doodles with elephants and other different things. But this is kind of a fun activity that if you're bored and you want to be nerdy, go ahead and do. Alright, if you guys have any questions, you can go ahead and ask me on Thursday when I'm back. Hope you guys have a great day. I will see you tomorrow.